In this problem, I've got a rod. It has a diameter of 15 millimeters, length of 200 millimeters, and loaded with intention at 300 newtons. Okay, and I want to determine the change in length and the change in the diameter. Okay, and of course this is knowing that my modulus of elasticity is 2.7 gigapascals, and my Poisson's ratio is 0.4. So the first thing I'm going to do is I'm going to go ahead and determine the stress that I'm seeing on this by using the tension load 300 and divided by the area, which is pi over 4 times the diameter of 15 millimeters squared. So the stress that I'm seeing right here is 1.67 megapascal. Okay, so once I have that stress, I can relate that to the strain through Young's modulus that I have here, which is 2.7 times 10 to the 9th pascals. Okay, again, my stress is 1.678 times 10 to the 6th pascal. From the relationship between stress and strain, then I can find the strain longitudinally to be this here, 0.0006288. Okay, now that I have that, I can easily find the change in length by just multiplying that strain times the original length of 200 meters. So I take the strain, take it times 200, and I find that the change in length is actually 0.126 millimeters. Okay, so find the stress, and then using Young's modulus, find the strain, and then just multiply times the length to find the change in length. Now, moving on to the diameter, I will do something similar. I'm going to find the change in basically the latitudinal strain, okay, using the relationship of Young's modulus, which is to say my Young's modulus is 0.4 multiplied times my strain longitudinally, which is 0.0006288. Okay, again, the negative sign basically tells me that I am having a negative lateral strain because as the length increases, the area decreases or the diameter decreases. So that's where the negative comes from. So it's just that relationship with Poisson's ratio of latitudinal strain and longitudinal strain. Once I get that, I can very easily figure out my change in diameter just by multiplying by the diameter, just like I did with the length, and I find that my change in diameter is a decrease of 0.00377. Okay, so again, there's a relationship between stress and strain, and also a relationship between latitudinal strain and longitudinal strain. We're using those combinations to figure out change in length and change in diameter here.